experiment. This is the second experiment. So the name of the experiment we are discussing about the second experiment in the digital part. So what was the first experiment? So to design and implement the half adder, full adder, half subtractor and full subtractor. So the design part is already explained for the first experiment, that is in the digital part. So coming to the second experiment, so you have to design it, okay, you have to design and also you have to implement it. Now understand the question properly. So design means you have to write down the circuit. So if you want to write down the circuit, as usual you want the K-map, okay. If you want to write down the circuit, you want the expression. So if you want to write the expression, you want the K-map. If you want to get the K-map, first you have to write the truth table. Okay, what truth table you have to write? You have to write the truth table for code converter. Code converter. Okay, you are supposed to implement what? Design and implement the code converter. What type of a code converter? Where there are n number of ways. Code converter means you can convert it from decimal to binary or from binary to hexadecimal. You can convert from one code to another code. Many types are there. But what type of a conversion they are expecting? So the conversion they are expecting is binary number to gray. Okay. So the binary data, the data will be in the binary format. So you have to convert it to the gray format. Okay. I'll just explain what is a gray numbers, what is the uses of it. All those things I'll explain after filling this table. Okay. After filling this whole table, I'll just explain you what is meant by a gray number or gray data. Okay. Next, you should also include or you should also implement gray to binary. Vice versa. Okay, binary to gray, okay, and from gray to binary. So this is how you have to this is what you have to implement in this particular experiment. Okay, so what is this binary to gray? Don't be confused. Many of the students, okay, as I have evaluated or as I have handled this from so many years, I know that, see, binary to gray means what they will do, here you have to towards the left side. So binary means binary should come towards the left side and the gray should come towards the right side. You have to find the gray numbers for the given binary data. Okay, many of the students what they will do, here they will write the gray number and here they will be writing B3, B2, B1, B0. That will be wrong. So binary to gray means input side is binary, output side is gray. Okay, here it should come G3, G2, G1, G0. Okay, have already written the expressions. For the gray G3, G2, G1 and G0. Okay, so now I have to, by making use of these expressions, I have to fill the truth table. So I have considered the 4-bit binary representation. Okay, so you can write the gray number for a 2-bit or you can write the gray number for a 3-bit also. But according to the experiment or what we are designing is a 4-bit. We are considering the 4-bit binary number. So therefore B0, B1, B2 and B3. And you are supposed to write 4 gray data, that is G3, G2, G1 and G0. Okay. So now first I will fill this particular column, that is G3. So how to fill this G3? So G3 is nothing but what, according to the expression, it is B3. Alright. G3 is nothing but B3. So whatever the data that is there in B3, the same data I have to copy it in the G3 also, because according to the expression or according to the equation, whatever it is there here, the same data will be shifted here. So therefore I have to write. So how I have written the binary data? So 010101, 001111, 4 zeros, 4 ones, 4 zeros, 4 ones, and 8 zeros and 8 ones. Right? So what is this G3? G3 is nothing but B3. Okay, the same data I copy it. So 8 zeros continuously. Okay, 8 zeros continuously and 8 ones continuously. Okay, so this is how you are supposed to write it for G3. Next, how to fill the second column, that is G2. See, from the expression G2 is equals to B3 XOR B2. This is what XOR operation. So what is XOR operation? So as I have already explained you, AB, Y is equals to A XOR B. Means how you will write? So 0 0 0 1 1 0 1 1. So what will be the output? So the 00 means your output will be 0. 01 means your output will be 1. Okay, 10 means your output will be 1. 11 means your output will be 0. So this is your output for the XOR operation. So how to understand this? If there are odd number of ones, okay, if there are odd number of ones, your output will be 1. If there are even number of ones, the output is 0. Here also the how many number of ones are there? 0. So 0 is a even number. So therefore I am writing it as 0. Okay, there are, just remember a single statement. If there are even number of ones in the combination, then the output will be 0. If there are odd number of ones in the given combination, then the output will be 1. So this is how you have to understand for XOR operation. The same applies here as well. Okay, the same thing applies here as well. So what they have given? So G2 is equals to B3 XOR B2, and again what the students will make mistake in this particular cases. So G2 is equals to B2 XOR B1 ಅಂತ ಬರೀತಾರೆ. B2 XOR B1 is a wrong expression. B2 XOR B1 is for G1. Okay, for G2 it is B3 XOR B2. Okay, you are supposed to perform the XOR operation between the binary data 3 and binary data 2. Okay, so these two things, okay, you have to perform the XOR operation on these two things. Okay, these two things will give you what? It will give you G2. So 0 means what is your output? It is 0. Again 0 0, all first fours will be 0. Okay, 0 1 means if there are odd number of ones, then your output will be 1. Okay, here also you will be getting, since there are odd number of ones from these two combinations, you will be getting it as 1. Next 1 0 1 1 0. See here, 1 0 means 1. The same thing. 1 0 1. Next 1 1. If there is a 2 ones, then your output is 0. So therefore the last four combinations is also 0. Understood? I repeat once again. So how to fill the second column? You have to just perform the XOR operation between B3 and B2. So how to perform the XOR operation? Just refer this truth table, then you will understand. Okay, fine. Now how to fill the third column? So to fill the third column, again use the third expression, that is G1 is equals to what? G1 is equals to B2 XOR B1. Okay, don't ever write B1 XOR B0. Okay, B1 XOR B0 is from G0. Many of the students will get confused between these only. It is a very easy experiment, but many of the students will get confused while writing the expression. If you are writing the wrong expressions here, you will be writing the wrong values here. If you are writing the wrong values, again your K-map will be different. If the K-map is different, the expression will be different. If the expression is different, obviously your circuit will be different, right? So therefore, do not make the mistake at the initial stage itself. Okay, remember properly, G1 is equals to B2 XOR with B1. Now, if you want to get G1, if you want to get gray one, that is G1, you are supposed to perform the XOR operation between the second column and the third column, that is between B2 and B1. So 00 means what? 00 means 0. Okay, 0 0 0 0 1 1 0 1 1 1 0 1 1 0 1. Double 1 means what? It is 0. Double 1 means 0. 0 0 means 0. 0 0 means 0. 0 1 means 1. 0 1 means 1. 1 0 means 1. 1 0 and 0. So this is how the value will get it for the third column, that is G1. Okay, and how about the G0? G0 is nothing but what? G0 is nothing but B1 XOR with B0. That is B1 XOR with B0. You will be getting the G0. So what is the answer you will be getting? So 0. So 1 and 1. 0 0 1 1 0 0 1 1 0 0 1 1 and 0. So this is the answer that you are getting for G0. Okay, so now how I have written this expression? So this is the formula that you have to use in order to get the gray data from the binary one. Okay, now it is very important to write the K-maps as well. So whenever you are writing the K-map for G3, G2, G1, G0, what will be the expression you will be getting? You will be getting the same expression. So you have to prove that. Okay, you have to show that this is the expression that you have got it from the K-map. We will see how to write the K-map for the same. Okay, we will try to get the same expression. Okay, obviously we will get the same expression because you have written the values by looking into this expression, right? So therefore, whenever you are writing the K-maps for this particular column, you will be getting the same expression. Okay. So now G3. I am writing the K-map for G3. So whenever I am writing the K-map for G3, what is the inputs that you have taken? You should not write A, B, C, D or P, Q or S. You have to take the data, whatever you have taken, to the left side. So B3, okay. So B3, B2, B1 and B0, okay. Next, also write down the cell numbers, that is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 and 15. Okay, so this is what the numbers that is there for the cells according to the rules. Okay, so what it is there in the zeroth column, sorry, in the zeroth position it is 0, in the first position it is 0, in the second position 0, third also 0, fourth also 0, fifth, sixth and seventh is also 0. And what about 8th? From 8th to 15 it is 1. So therefore it is write it as 1. Okay. So now if you just think about the priorities. So first priority we have to give it for octet group, and next comes the quad, next comes the pair, and finally it comes to the isolated one. So if you just observe here, there are 8 ones continuously. So therefore I can very easily make a group as an octet, right? So this is an octet, okay? So what will be the expression for this? So what will be the expression for this particular octet? If you just grow this horizontal, if you just grow this whole group vertically, then it will be touching 0, 0, okay? It will be touching 0, 0 of B1, okay? But it is touching, say, in all B0, B1, both the variables will get cancelled. How it will get cancelled, I will just explain you. So 0 and 1. 0 and 1 is touching, and is 0 and 1 is with respect to B0. So B0 get cancels. Next, 1 and 0. 1 and 0 is with respect to what? 1 and 0 is with respect to again B0. So therefore, it get cancels. So therefore, this B1 and B0 will get cancels completely. Okay. Now, if you just observe towards the left side vertically, whenever you are growing this particular group towards the left side horizontally, you are getting what? B2 will also get cancels, because B2 is changing the value from 1 to 0. So B2 get cancels. So B3 is left over. Okay, B3 is left over. So therefore, I have to write it as B3. Have you got the expression G3 as B3? Okay, so therefore G3 is equals to B3. So this is how you are supposed to write. And there is no need to map towards vertically, because it is touching all the variables. Since it is touching all the variables, everything get cancels. Right? Okay, fine. Please take down this, then we shall go for the next K-map, that is for G2. Okay? Next, let me write down the K-map for G2. So the K-map for G2 0, 0, 0, 1, 1, 1, 1, 0, 0, 0, 0, 1, 1, 1, 0. So this is B3, B2, B1 and B0. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 and 15. So these are all the cell numbers that is there for the K-map. Okay, so let me fill this. So first 0, 0, 0, 0. Next 1, 1, 1, 1, 1, 1, 1, 1, 0, 0, 0, 0. It is very easy. So just copy down the same thing, whatever that is there in the second column into the K-map. I have already explained you how to transfer the values from the truth table into the K-map. So okay. So now you just think about the rules. So whether is the octet possible? Octet is not possible because there are no 8 ones continuously. So therefore the octet doesn't come into the picture here. So now, okay, now you have to think about the quad. So is the quad possible? Yes, quad is possible because there are 4 ones continuously. So let me group like this. So this is one particular group and again this is another particular group. So let me write down the expression for this. There are 2 quads now. So what is the expression for this one? And if I grow vertically like this, it is touching all the values, so it gets cancels very easily. And if you are growing vertically like this, it is getting mapped to what? B3 and B2. Okay, it is getting mapped to this particular value, that is B3 and B2. What is B3 taking? B3 taking as 0, so therefore let me write it as B3 bar and also B2. And what is the value? What is the expression for this particular quad? And again, if you grow horizontally, if you grow vertically like this, it just cancels B1 and B0 completely. So therefore, whenever you are growing horizontally towards the left side, it will be touching or it will be mapping B3 and B2. So B3 is taking 1 and B2 is taking 0. So therefore, let me write down B3 and B2 bar. So what is your G2 expression? So G2 expression is B2 bar plus B3 bar to B2. So this is nothing but what? This is in the format of XOR only now. So what does the XOR operation tells? A into B bar plus A bar into B in the same format. So therefore let me write down B3 XOR B2. Okay. So this is the expression that we have got for G2. Have you proved this? You have also proved this. We have also proved B3 XOR B2. Right? So the left out is G1 and G0. Okay, we'll do for that as well. Okay, please copy down the same thing. Please copy down the same thing in your observations very properly. Okay, do not make any mistakes. Follow the rules that whatever I have told and follow the numbers that whatever I have written in the cells of the K-map. Okay, fine. Now let me write down the K-map for G1. Okay, let me write down the K-map for G1. Okay, so 0, 1, 2, 3. See, even though you know the cell numbers, even though cell numbers are in your mind, please do write it. Okay, if you are not writing the cell numbers, then you will go wrong. 9, 10. 11, 12, 13, 15 and 14. Okay. So now let me start filling it. The table, the third column. Okay. So first is 00. Next is 11. 4, 5. Okay. Next is 4 zeros. Okay. 1, 1. Okay. So this is how you are getting. Okay, this is how we are getting. So if you just observe here, so there are 4 ones continuously. So therefore, very blindly you can make one particular quad, and there is no output possible. You can very blindly go for it. And again, if you see these 2 ones, yes, it is continuous. So therefore, I can go for a pair. But think about a quad. Is there a possibility of a quad? Since this one is at the extreme corner, you are supposed to check the another extreme corner. So again in this extreme corner also there is a 1. Okay. So therefore here also there is a 1. So therefore again there is a possibility for making the quad. So here you are getting the 2 quads. Okay. So what is the expression for this particular quad? What is the expression if you are growing the vertically? It is touching both B1 and B0, and B0 get cancels because it is taking the value 0 and 1. But B1 comes into the picture, and that B1 is B1 bar because it is taking the value 0. Now, if I am growing horizontally towards the left side, it is touching what? B2. So therefore, let me write B2, and B3 get cancels. B3 get cancels because it is taking the value 0 and 1. Next, if I want to write the expression for this particular quad, then how to think or how to write the expression? So the quad comes in which row? The quad comes in this first row and the quad comes in the second row. So therefore just think about this part and this part. So this is getting changed to 1, that is B3 is getting changed to 1, 0 is getting changed to 1. So therefore forget about B3, then B2 is not changing it is remaining constant, that is from 0 to 0. So let me write down as B2 bar. Okay, let me write it as B2 bar. So now you have mapped the rows. Now think about the columns. So which are the columns that is coming into picture about this quad? It is only the third column and the fourth column. So just third and fourth column. So these are the two things that you have to look after. So now this B1 is remaining constant, but B0 is getting changed from 1 to 0. So therefore you can forget about B0. So what is B1? B1 is 1. So therefore I can directly write it as B1. So what is the G1? G1 you are getting now B2 bar B1 plus B1 bar B2. That is nothing but what? B1 XOR B2 only now. That is your G1. Okay. So this is what we have proved. This is what we have proved. Understood? I hope you can go for G0 as well. You can do it by yourself. Anyway, I will explain in the also. Please copy down all these things properly in your observation book. Okay? Fine. Shall I erase this? Let me erase this. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 and 15. Right? Just fill this one. Okay? 0, double 1, 0, double 1, next double 0, double 0, okay? Next double 1, next double 0, next double 1, double 0, next double 1 and 0. Okay, and there is a mistake there. Okay, 0, 1, 2. You have to just copy it. You have to just copy this one into this K-map, that's all. So if you just observe here as well, if you just observe again, there are 4 ones which are continuous and there are no 8 ones continuously. There are only 4 ones continuous. So therefore again you can go for a grouping. That is a quad. This is one particular quad and this is another particular quad. So now the very easy thing to write down this expression is, so let me grow vertically like this. If you are growing this particular group vertically like this, it is mapping with respect to what? This is G0. Okay, we are writing the K-map for G0. So whenever you are going vertically, it is touching what? B1 and B0, and it is taking 0 and 1. So therefore very blindly you can write down B1 bar and B0. And what about this? Whenever I am going vertically like this, it is touching B1 and B0. So that B1 is taking as B1 and B0 is taking as complementary. Okay, and if you are going horizontally, then it is touching all the values. So therefore it gets cancelled. We are not bothered about the grouping that is with respect to horizontal. So you are getting G0 is equals to what? B1 B0 the whole B1 B0 bar and B0 bar into B1. That is equals to what? That is equals to B1 XOR with B0. Okay, that is what we have proved. Okay. So now I was telling that you are going for code conversion from binary to array. What is the use of it? Okay, if you are doing some conversion, you should have some application of it. What is the use of it is, so if you just observe this, if you just observe the first row, if you just observe the first row or first combination with the second combination, so how many number of bits are getting changed? There is only one bit that is getting changed. So 0 is left 0, 0 is remained 0, and the 0 is getting is remained to 0. Only this 0 is getting changed to 1, right? There is only one bit change in its position. That is a very important application. Okay. So now, if you compare the second combination with the third combination, how many bits are getting changed? See, 0 is remained like that only, 0 is remained like that only, 1 is remained like 1 only. So this 0 is getting changed to 1. So if I compare the third row with the fourth row, or with the third, if I compare the third combination with the fourth but this 1 is getting changed to 0. Okay, so now if I compare the fourth combination with the fifth, again the same thing. So if you just observe the combinations, there is only one bit change in its position. There are no two bits change in its position if you compare any of the rows. For example, if I am comparing this row and this row, so which is the bit that is getting changed? This is the bit that is getting changed. So the gray representation for this particular combination is this. So the gray representation for this particular binary combination is this. Okay, the gray representation for this particular combination is this one. So now, what is the use of this? What is the use of this is, so this particular data will be used for encryption. So encryption, decryption, all those things you will be understanding in the further semesters. Whenever you are studying about the network security or the cyber security, whenever you are transmitting the data from one point to another point, so in between there may be chances of losing the data, or there may be chances of duplicating the data by some other third party. Okay, so for example, I am transferring the data as 1110. Okay, 1110 I am transferring. Okay, 1110 I am transferring from one point to another point. If the third person is duplicating it, then you will easily get to know that which bit is got duplicated, because if you are coming from one combination to another combination, there will be only one change in its position. Okay, if the third party or if another theft is stealing your data from the communication protocol, then you will easily get to know which bit has been duplicated. Okay, so that is one such an important application of this. So one important thing what you have to remember is, so whenever you are converting from binary to gray, you have to use this expression. And what is the speciality of this gray code is, if you just compare the first combination with the second combination, so the binary representation is only a change in one bit position. Okay, so if you just compare this, if you just compare the binary representation of this row and this row, how many number of bit positions are getting changed? See, this is one bit position that is getting changed, and this is also one more bit position. So two bits are getting changed. So whenever you are sending the binary data in your communication protocol, even if the third party is duplicating, then it is difficult for you to get to know which particular bit has got changed. So therefore, in the encryption and decryption, you may use this gray code. Okay, so this is the gray equivalent for. And in the exam, they may ask, what is the gray representation for 4? What is the gray representation for 4? So how to answer this? In the Viva also they ask what is the gray representation for 4 means. First you have to write down the binary representation for 4. That is 0, 1, 0, 0 is the binary representation, right? So the binary representation for 4 is 0, 1, 0, 0. So this is what B3, this is what B2, this is B1 and this is B0. And they are asking to write the gray code for 4. So how to write that? So you have to use this formula. So G3, G2, G1 and G0. So G3 is what? It is just B3. G3 is just B3. What is G2? G2 is nothing but what? B3 XOR B2. 0 XOR 1 is 1. What? It is 1. What is G1? G1 is nothing but B2 XOR B1. That is 1 XOR 0 is again 1. What is G0? G0 is nothing but B1 XOR B0. That is 0 XOR 0 is 0. So this is the gray code for 4. What is the gray code for 4? Gray code for 4 is 0 1 1 0. Have you all understood? So this is the application part. Okay. So now we have to implement the circuit as well. So how to implement the circuit? It is very easy. Okay. Just take down the circuit. Okay. Just take down the expression and write the circuit. Okay. We'll see that. Copy down till here.